integers.
Okay.
Okay, the words corresponding to integers. Remember, there's an integer which is a number, and there are strings which would, because words are strings, and strings are a bunch of characters. So they're trying to clarify between integers and characters. And what they're saying is that you create words. So your first such word. Oh, sorry. Use this pen. What they're saying is that the first possible word is simply the number 1, okay? Because that's the first, as they say, that's the first word. It's the character string that corresponds to 1. The second possible word is going to be, yes?
Two.
Sorry?
2.
It's going to be 1, 2.
Okay.
Right? Because you have to take the second word is really, you take the first word and then you concatenate the string corresponding to 2, right? Is that clear?
So is it like,
No, are you understanding this? I need some validation from you guys, otherwise I'm not answering questions yet. What part of this didn't you understand?
so the one, is it like the index of an array kind of like thing?
Sorry?
Like the word is 1, and then the second, I don't know how is the second word 1, 2. Like from what I'm getting is you have a list of.
So, let's read this here together.
Oh, you left them.
Hey. All right. So it says the kth word, so in this case we're talking about the second word, is obtained by writing down the first k positive integers. That's 1 and 2. Those are the first 2 positive integers. Yes?
Yes.
Yes?
But the K is
Okay.
like.
Hold on. And then concatenating them together. So I concatenated 1 and 2, and that's how I got that. Yes?
I think I'm getting it. So that means the third one will be 1, 2, 3, or
Right.
whatever it comes out.
Right.
So in the second input, that would be like 1, and then the second one would be 1, 0, and the third input would be 4. 1, 0, 0.
1, 0? Where do you get 1, 0? I'm sorry.
It's from
I lost
input
you.
sample 2.
Don't bother with this yet. Let's come back. Let's make sure we understand this. Are you guys clear about this?
Okay, so I guess the order also matters too, right?
Oh yeah.
Okay.
Oh heck yeah. It
Okay.
has to be in the right order.
Okay.
It has to be the first k positive integers, and you have to concatenate them together. That's a good question. Is the order important? Is the order important? It is. At least according to the solutions these guys turned in, yes. But it's not clearly specified.
Yeah.
I agree with
Oh.
you. All right.
Because like I was trying to like relate it to like actual words, like different order of
I got it.
letters
Yeah.
can form
Yeah,
different
yeah.
words.
No, I think you're right. They should have said that more clearly.
They sometimes miss those details.
Yeah. And sometimes it takes good questions to figure out what they missed saying. But yeah,
This is like
so
green
so
one.
so really your problem is you're given some word, you're asked, is it one of these strange Champerdon words? That's all. How hard can that be? So can you do this? Now, there's also another important constraint here, which kind of really destroys this problem, makes it way too simple. It says the numbers are never more than 10 to the 9.
Yeah.
So really, there aren't that many possible numbers you can write down. In fact, there are only 10 possible words you can write down. Right? Is that clear? So, if it's not one of the things that we've listed out here, which is 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, if it's not one of these, just say no. Is that clear? All right, can we move on, please? That was just ridiculous, yes? Okay, let's get to something more interesting. Okay, well, maybe, yeah, let's try that. Yes. That's the one you guys, oh no, case. Says truth speak. All right, here's another one. Take a read. Not as silly as this one here. Making sense? You want to explain the problem to us as much as you understood?
Okay, so I'm guessing that the threshold would be like the
No,
proportion.
tell us the problem.
Oh, okay.
Start
You're
from
trying-
scratch. We didn't read anything. You don't know how to read, now tell us.
Okay. You're trying to convert a bunch of casual runners to serious runners.
Serious runners, thank you, yeah. Then, how do you do that? By making sure, what?
By making sure that the casual runners feel the need to want to catch up to the serious runners.
Yes. Well, so
Oh, to-
you put enough serious runners in there
Yeah.
in order to convert the casual runners. If they aren't, if the number of serious runners is too small, nothing happens, right? Okay, so. Everyone okay with this? All right, then it says that if there are some numbers here. It says if this many casual runners and this many serious runners go together, if that ratio is blah, 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 then all those casual runners will become serious runners, right? That's what it says. All right, so let's apply it to some examples here. Let's take the first one. It says 9, 5, 5, 6. What does that mean? So n is 9, which means there are nine what?
Serious runners.
Serious runners, is that it?
Yeah. Okay.
And 9 serious runners. Okay? And then we have 9, 5, 5, 6, so that's 5 casual runners, right?
Yeah.
And then A and B are numbers that you're going to use to figure out this threshold thing, right? So A is 5 and B is 6. So A divided by B is 5 divided by 6. Is that clear? So that's your threshold. That threshold says if you don't have at least 5/6 of the runners being serious runners, nothing is going to happen. You're not going to help your program, right? Okay, so
I'm sorry to go a loss. So the AB is serious over casual, but the X over X plus Y means that it's gonna be like serious over serious plus casual. So it wouldn't not be the same no matter what.
sorry, say that again.
If
Oh, so you're right, so it's not, it's, I didn't get that. Yeah. Yeah. So it says that if six runners go running, unless 5 of them are serious runners, you're not gonna convert the sixth one. Is that clear?
Yeah.
No, I'm not gonna. What do you mean you're not gonna convert it to?
That's what it says. If 6 runners go together, and if only 5 of them, if 5 of them are serious,
then
and if the 6th one is not serious as a casual runner, you will convert that person. Clear?
But if it was a casual runner, then they wouldn't convert.
Sorry?
If it was a inverse, it wouldn't convert.
Oh, yeah, well, anything less than 5 is not gonna do it. If 4 and 2 won't do it. Okay? Or 8 and 4 won't do it. 8 and 3 won't do it. Is that clear?
I guess what's wrong the opposite, A and B is like X and Y.
A and B are just numbers. Why are A and B bothering you? I don't quite follow.
I think she's talking about the, on top it says X over X plus Y.
Yeah.
Where X is the serious runners and
Right.
Y is the
Agreed.
casual runners. That's
But,
But if A is serious runners and B is casual.
so I didn't say this is, I didn't say A is
No,
serious runners.
that's
and
just
B
the
is-
threshold.
That's just the threshold.
Yeah.
So it says that the number of serious runners divided by the total number of runners, you're right, so B should be X plus Y, not, yeah, yeah. So what you want is,
Oh, okay, I get it now.
that's why I said if you need to have 5 serious runners out of every 6. Otherwise, you're not changing anybody's mind. Okay? All right, so how do I start to convert more people? Now remember, there are 9 serious runners and 5 casual runners. You gotta go and change the minds of 5 people. How are you gonna do this? Come on, guys.
Oh, okay. In the context of the problem, you have to use
You have to
the
use-
general formula provided.
You have to use the numbers that
Yeah.
you have. Yeah, so tell me, what are you gonna do first?
So first, you have to set a threshold. That's the
The
first.
threshold is set, the threshold is
Okay.
given to you, you're not
Yeah.
messing with the threshold, you cannot mess with the threshold.
Okay.
Then, I guess you use the formula X over.
Alright, so just, there are, this is my club, okay? I have A, B, C, D, E, F, G, H, I, J, 3, 3, 6, oh, I have a bunch of them. Oh, so that erases.
Yeah, you erased it.
Oh, I did erase it, okay. So I have 9 people, serious runners, and then, let me say, I have 5 casual runners, so let me
You
call
have to
them.
switch back to the pen.
Sorry?
You have to switch back to the pen.
Switch back. Thank you. Why doesn't it go away? Okay, so let's say I have lowercase a, b, c, d, and e. These are my casual runners. Now, how am I going to change their minds? What's my plan?
Okay. Get the number of serious runners would motivate them to to push them to be more
That's
serious
right.
runners.
So, how many can I change in one round?
So pretty much you have to reuse series runners, like you have to make like different rounds.
You have to reuse serious runners. That's why the answer is, it's asking how many rounds do you need?
So
Right?
this would be the, oh my gosh, this is
Oh,
the
the
math
output is the
question.
number of runners, right? Okay.
So I just gave you some names here, but really it doesn't matter.
Mhm.
Okay? What do I have to do? So in order to change the mind mindset of 1, I have to have how many series runners?
5.
5, right? So I'll just take the first 5 people and have this group run with A. Yes?
Yes.
Done. I've changed the mind of A. Could I have changed 2 people's minds in 1 round? Why not?
You need time.
Because I don't have enough of these series runners. But now that I have changed the mind of this person, what do I have? That goes here.
Oh, so it's gonna add more to the series runners.
That's right. So now what happens?
You have 10 series runners.
Now I have 10 series runners, so
You have
I can
4.
change the mind of
2.
2. So now I'll get all 10 series runners to run, and I'll pick the next 2. Yes?
Yes.
And that'll take care of both of them. And then in 1 more round, I can get the other 2. So the answer says I need 3 rounds. That's what you say. Yes? Everyone clear about this?
How would this look in code?
Sorry?
How would that look in code?
Good question. Okay, so it's a greedy algorithm. You want to employ as many series runners as possible and change as many of these casual runners as possible. So you know that you started with 9. So you start n with 9 and k with 5. For each one, you're going to need 5 runners. That's what this says, right? So 5/6 means you want a ratio of 5:1, series to casual, right? Is that clear?
5 to 1. Okay, yes.
So if you have 5 series runners, if you want 1 casual runner to change their mind, then you need 5 series runners. Well, you look at 9 and you divide that by 5 and figure out how many you're going to make, how many you're going to change in 1 round. That tells you only 1. Done. Then you iterate this again. Then the next time you'll have a new number because some have been changed, and so then you can figure out how many of the next time it'll be 9 plus 1. Then you do 10 divided by 5 and you get 2, and then you keep going.
I see it.
Now you see it all. Okay. All good?
But the numbers can be really big.
The numbers can be really big. So let's take a look at what the constraints are. Good point. So let's do this. So the numbers can be as big as what?
10 to the 9th.
10 to the, where is it?
10 to the 9th.
10 to the 9, yeah. So all these numbers can be as big as 10 to the 9. So the question is, can you afford to go through this many times?
Oh, I'm confused.
This number can be as big as 10 to the 9.
No,
Sorry?
I don't think you can afford to.
That's right. So you got to come up with something faster.
I'm confused. What do you guys return?
No, like, so in a case you have like, a lot of runners, like, would it be efficient to like, iterate through all of them? No. Like, let's say you have like 1 billion runners, right? It would not be efficient to like
I thought you were
iterate
going through it
through all of them.
recursively. Because if you just.
It's not recursively, it's iteratively. Because the way I described it and the way you understood it, we're going to we're going to figure out how many, what is the maximum number of casual runners you're going to convert to serious runners in 1 round. And so you figure that out, and then you add that to the number of serious runners, and then you redo this, right? Now, if you keep doing this, if n is very, very large, generally actually if k is very large, then you're going to keep changing just a few minds every time. And if k is very large, it's going to take you a large number of rounds to do this, and so therefore it doesn't work for you. So what do you do? So this becomes a slightly more involved math question now, because you can figure out right at the start how many casual runners you can convert to serious runners in one round, right? Now that number will then add up to the number of serious runners, and the question is, how many more times do you have to do this before that number increases by at least one?
What was the when you did the normal iterative before the constraint was an issue?
Yes.
The math, you divided 9 from, what was it again?
You tell me.
9 serious runners, and you divided that from the amount.
Okay, so right. Now you started with n runners. You did n divided by k, and you did a floor function. That tells you how many casual runners will get changed to serious runners. The next time around, you're going to get n plus the same number, n divided by k, and again you're going to divide this by, well, actually you're going to divide this by k minus n divided by k. Sorry, it's not n divided by k, it's n divided by, sorry, let me erase this again. Alright, so if your threshold is a divided by b, then really for every a series, for every a series runners, you're going to need b minus a casual runners. Or rather, for every b minus a casual runners, you're going to need a series runners, right? Now, what you can do is to figure out how this number will change. So you're first going to do n divided by a, right? And you take the floor. That's the number of casual runners you're going to be able to change the minus out, right? And then this will become, after the first round, this will become n, the number of casual runners will increase the next time around, and that will increase by this many, right? So plus n divided by a, and then you're going to divide this by, again you're going to divide this by a. Is that right?
I can't
Yeah.
really see.
Sorry?
I couldn't see.
Yeah, again, it's going to be divided by a. And if this is different from this, then you know that something is going to change. If it's not going to be different from this, if these two are still the same, then you can just keep repeating this multiple times. And the question is, how many times do I have to do this before it changes? So the next time around, this is going to be n plus 2 times n over a, right? Divided by b. So this tells you the number of rounds, and so let's, after k rounds, you're going to get n plus k times n over a, divided by a, floor. So you want to know how long is this going to be equal? Well, I shouldn't use this k here. I should use something else. Use the number k. So you want to know how many times I have to do this in order for this number not to change. And so you can figure out how many iterations I can do with no change in the number of casual runners that I will will convert. And so the P will simply multiply whatever number you get here. That's the number of P multiplied by the number of casual runners you increase, and that's going to be your final answer after P rounds. Then you restart this process with the next value. I don't know if there's a faster way to do it. I haven't quite thought this through. If you guys remember how you did this, you're welcome to.
We didn't do this because I was thinking about it the opposite way.
Uh-huh.
But I assumed my time complexity was going to be bounded. Turns out that the way I was thinking about it was wrong.
But
It's
did
the number.
you submit this answer and it
No.
didn't work?
No, the number of iterations in
Was
this
just too
solution
large.
is square root n, right?
In what I'm proposing here.
Because at each point it can increase by 1 in the least, and maybe in the really worst case you have to do this up to square root n times.
Yeah, because you get this a squared here. Yeah, possibly. Yeah.
I was
Okay.
binary searching to solve this,
Uh-huh.
and I was getting TLE. So it has, you have to.
You're saying this is not going to be.
No, I was saying this is fine. It's just instead of writing a formula for this,
Uh-huh.
I used binary search, and then it made it too slow.
Oh,
So I got like square root n log n or something.
I see. Yeah.
But this was fine. I tested it once I got home.
So you have to solve this math problem of what the value of P is in order for these two to be the same. Once you do that, then you know that for P number of iterations, the number of conversions is going to remain the same.
What
Okay?
I'm a little bit confused on is exactly what does P stand for? I know you say number of iterations, but I
So-
did not see.
I started with this, right?
Mhm.
I have n people, and I can, as long as I have a series runners, I know I can convert b of them. B minus a of them. Right? Now, after one round, this is what I get. I get n plus n over a as the number of series runners,
Mhm.
and the number of casual runners went down. But now I have to restart the process, and now I have a new number of series runners. I divide that by 8 and I ask how many casual runners will I convert. I keep doing this. As long as I get the same number as this, then my situation hasn't changed, and that's my P.
That's why I'm being a little confused. So when you say the number of casual runners is going down,
Yeah.
what is A? what
A
is-
and B are fixed. There's no argument there. A and B simply defines a threshold. As long as in a group, there are A series runners and B minus A casual
Okay.
runners, you're going to convert B minus A casual runners.
And then. Okay, I'm getting it. It's a lot.
Yeah, understood.
So I guess one thing with the problem, isn't it always fine to just take all the serious runners? It doesn't hurt you at all.
Yeah, it does.
It just makes the
Right.
math a little messy.
Well, it's that's why I am taking all the series runners.
Okay.
I could have just stopped it at the last. So by taking floor of n over a, I'm essentially doing what you're saying.
Okay.
Yeah. The question is how many casual runners should I employ in the first round? That's this number.
Yeah. Mhm.
Right?
Yeah.
Then those guys are all going to get converted, and then all those become serious runners now. And so again, I do the same calculation. And the question is, how many times do I do this and not have the answer change? That'll tell me how many essentially identical rounds are going to happen. Yeah.
And between arrows, each of those numbers inside the floor
Yeah.
operations is the number of casual runners in that round that could be converted.
Yes, that's the maximum
Okay.
number of casual runners
So
we
then-
know how to convert.
Then I'm kind of curious because in the third round over,
Yeah.
you're just multiplying the original fraction, floor n over 8,
Yeah.
You're adding that to make 2 times that fraction, instead of
I'm
adding.
not doing 2 times that fraction. You think
No,
this
I'm
is
talking about in the next round, like after that.
Oh, I see. Once this P rounds are finished, you mean?
I'm talking like from the second round to the third round. The coefficient changed. So now you're adding.
Correct.
Yeah. So I'm wondering why it is that you're not just adding the results of the previous 2 rounds, which would be floor n over a and floor n plus floor n over a divided.
Because I'm only allowed to do that if this number is not different from this.
Okay.
I'm asking how many times do I have to do this, and each time the number remains the same.
What do
So you want to find the first such instance that like the.
Yeah,
round
because
round
then then life is different, because now I'm in each round I'm changing a slightly I'm changing more number of casual runners. Here all these are rounds where the number of casual runners that are becoming serious runners is exactly the same. Okay, and I'm asking when do I stop? In our example, right after that first round, we were able to jump to 2, but then we were only able to convert 2 at a time. If that problem, instead of 9556, if it had been 9756, then I would have asked how many times do I have to convert 2 before it becomes 3,
So then
or
you're-
if at all that's possible.
So then you're bounding it by saying that until some certain point in the future, we're only ever going to convert some fixed number of casual runners, and you
Yeah.
want to find the last point when you can do that, like when it changes.
Yeah, right, exactly, yeah.
Is n over b, you're saying the number you're gonna take at that first iteration?
N over?
That n over a floor,
Yeah.
you're saying that's the amount you're gonna take?
That's the number of casual runners that I'm going to, that are going to be converted in each round.
Shouldn't it be n times b minus a over a floor?
Wait, N over A, no, that's the number of casual runners that get converted.
Can I write something?
So tell me what's the
So
problem?
I'm saying, like, if we go back to the original formula, x over x plus y,
Yeah,
you just substitute x with n, because that's the amount of people, and make that greater than or equal to a over b, and then just solve for the y.
same thing, you'll get exactly the same thing.
I got something else.
So repeat for me.
So,
x
yeah.
over x plus y says that this is the threshold, this is A over B, right? This is exactly A over B.
It has to be, whatever you do, it has to be, that has to be greater than or equal to a over b.
Yeah.
Just by the definition.
Right. Well, you will convert y if this is greater than A over B, correct?
Yes.
Yes, agreed.
And then what I do is I substitute x with n,
Uh-huh. Okay.
and then just solve for y.
N over n plus y.
It's greater than or equal
A
to.
over b. And then you're saying in this case, it's going to be
Bn.
9 divided by 9 plus y greater than 5/6. This is what you're saying, right?
Yeah, and then solve for y.
So 54 greater than 45 plus y, and so y is less than 9. What? Sorry. Y has to be less than 9, sure.
Yeah, I just meant that it doesn't boil down to n over a. There has to be multiplied by b minus a.
I'm not quite following this, but I'm gonna stand by this here. So let me think about what you're saying one more time.
Can I write one step below it?
Okay.
I was saying,
Find some space here. Hold on. You can write in this corner.
Ricky, what does that number like mean in the context of the problem set? Is that like the maximum in a
this is
single round?
the number you're gonna take of casual runs.
So like y less than 9 means like in the context of the problem, like we can take in a round with n
Less-
people.
Less than or
at
equal to, yeah. Oh, actually,
But we
okay,
might,
so
we might not have that many people.
let me solve this. Yeah, but that's an implementation thing. You have n plus y is less than or equal to a over b.
Yeah.
We're gonna solve for y, so we get en less than or equal to an wait, plus
Yeah.
ay.
Mhm.
I'm gonna move this term over. So
Mhm.
bn minus an ay, and then I'm gonna just
Divided
factor
by
out
A, so it's d by A,
bn
and,
minus divided by a.
yeah,
And then I have for n, b minus a over a. So it should just be the floor of
6
that.
minus 5,
Professor, there, when you multiply 9 plus y by 5, it's gonna be 5y, so that's gonna give you like.
I made a mistake there.
Yeah, that's why it's weird, y is less than
Yeah, you're
9.
right.
If there's 5y, it's, I think, y,
Y less than 9.
yeah, then it's the same thing, then it's 1.
Yeah, isn't that what? I think
Then
that's what you were
y is
saying. Yeah.
one.
Then y is
Floor
one.
9 over 5.
Alright.
Yeah.
Okay. Thank you for catching that. Okay. So are you pretty much getting the same?
Yeah.
Okay.
Yeah.
Thank you. Yeah. So let's step back again, recap what we did. What we said was that if we start with, even if we take all the n series runners and ask how many casual runners should we group with them in order to convert them, that number is n over a, right? The next time around, in the next round, I'm going to have that many extra series runners now. I could employ all of them and ask how many casual runners am I going to be able to convert. That number is that new number divided by a floor. Now, what we want to know is how many times do I do this with the numbers not changing?
What do you mean with the number not changing? What's not
Meaning this number is the same as this number. If it's not changing, then you're going to continue to do the same operations and you'll run into the problem that we started with, which is you have 1 billion people and you're not going to be, you're going to spend way too much time trying to figure this out. Because in each time you're only going to get rid of a few and you'll just keep beating away and you'll spend way too much time.
I don't think I'm on the same page.
Sorry?
Because what you're doing is you're splitting, you're getting the number from the last round and you're adding it to the, where is this two coming from?
Sorry?
The two in this part coming from?
Now I've converted that many people more.
Because this is how I drew it now, like, page drawing, I don't know if I'm on the same page. This one would be.
That's the same. That's
It's the same?
exactly the same.
Okay.
Okay. The reason, so we came up with an approach first, and it worked. The only problem was it was going to be too slow. So we needed something faster. Zach, are you fine with all this so far? We came up with a simple way, namely, take all the series runners, figure out what's the maximum number of casual runners we want to put with them, and convert them. We keep doing this, eventually we'll convert all the casual runners. Let me finish, no, hold on. So, we keep doing this. The only problem is if the numbers are too large, it's going to take you forever. Okay, so you got to speed up the process. How do you speed up the process? You try and figure out how many rounds you're converting the same number of casual runners. If you can figure that out by a formula or by some other technique, then you can just multiply that number and jump to the next step. Does that make sense? That's what we were trying to do. Now, how did we do this? We said the first time around, that's the number of casual runners we can change. Now, these casual runners are now going to become series runners, so the numerator changed. And this time around, this many casual runners will change. But if it's possible, since you're doing a floor, it's possible that it's not any different. And you might end up doing this over and over and over again, and each time just getting the same answer. You want to know how many times I'm going to do this and still get the same answer. so that I don't have to do this so many times. If this P itself is 50,000, then you're gonna do 50,000 times the same calculation and simply not get anything different. So we're trying to estimate that 50,000 and then saying, let's just move forward to the next step. Did that make sense? I don't see any heads nodding.
I'm still trying.
I'm explaining it for you guys. So help me out.
Are you saying that after a certain amount of iterations, that the ratio is gonna be the same ratio, therefore you're gonna continue making the same
That's
ratio?
right.
So at that point,
So
don't
we-
you wanna reduce it to make it that it's the simplest form of that ratio?
This is the simplest form. N plus P times N over A divided by A.
But instead of adding, continue increasing the number, why don't?
But the numerator did increase. That's the only key. I need to figure out P. That's my variable. You were gonna say something.
No, I was still thinking in terms of like B minus A. I know that that's for the threshold. Like you do B minus A. Cause like if you do 6 minus
This
5, you get
tells
1,
you,
right? Yeah.
this tells you that on every run,
Yeah.
if you're going to try and convert this many,
Yeah.
you better have this many series runners.
So for instance, so B minus A would be, in this case, 6 minus 5, 1. So in the first iteration, that's like how much casual runner you would convert to a serious runner, just one, right?
Yeah.
And then you try to keep that, but wouldn't that change over time? Like wouldn't that
What will change? The
like,
number of series runners?
No, the amount of runners you have to the amount
A and
of
B are
casual runners
fixed.
you have to convert.
A and B never change.
Okay.
What changes is N and K. The number of series runners goes up, number of casual runners goes down. Right? Are you with me so far?
Okay. Would that be P in this case? Or would that be P in this case or no?
No. P is something I'm trying to figure out in order to shortcut this darn thing. Because otherwise I'm just going to be hammering away gazillion times simply to get the same answer. Right? Why recompute when I'm going to get the same answer? I want to know how many times do I repeat this and not end up changing the number of casual runners I'm converting. Right?
We have to compare with the K because every time
Wait, no, K is not relevant.
not the
Oh, you
casual
mean-
runner. You know?
Oh, you mean if we're out of casual runners?
Yes.
Well, you can check that at the end of this because this is a direct calculation of P, and if P already takes care of all the casual runners, then the game's over. Yeah. You're right. So that's something we'd have to do after we calculate P.
I don't know if
Okay.
we're on the same page, but this is reminding me of this math question that we did where you had this. I don't remember exactly what it was, but this guy was given this formula where he had to calculate how many something about if this. I just don't. I remember exactly when I discussed it, but I don't remember what was. It's something with 100, and if this keeps on going on, and he created a formula that. I just don't remember.
My advice is forget all that. Think afresh, think about this, and tell me what it is that you don't understand. And that
But I
goes for
think you
you.
can use that
I need to hear a yes from you. What part of this didn't you get?
Can we look at the
Problem?
problem? Of course.
Okay. Don't get lost in all this language here. That'll only confuse you. The point is, I need enough for every casual runner. I need enough serious runners to convert them. Okay, to dilute them out. Now, in any given round, I have this many serious runners. So how many casual runners can I change? Are you following this? Are you following this? Yes?
Yeah.
This many casual runners I can change in one round. Now, if after the first round, this many casual runners became serious runners, how many serious runners do I have? That number went up, right?
So I guess P would be the number of rounds, right?
P would be the number of rounds in which the number of casual runners I converted remained the same,
Okay.
right? And so all I'm saying is after P rounds, this number is still the same as this. What is that value of P?
Okay.
That's what I'm asking. N keeps creeping up, right? At some point, it's going to hit something, and this ratio is going to go up, jump up by 1
Okay.
or more. I don't know. And the question is, how many times do I have to do this? Will it always only go up by 1?
A worst case scenario, it goes up just by 1. So at most you need like square root n iterations of this.
Yeah. So there may be a way of writing down one more formula for it. Anyways.
Yeah, I think I got the next element formula. If I can write it down.
Sure. You were gonna say something.
It's gonna be this number is we're gonna compare it with this equation to you write it y less than the a that
You're happy with this?
yeah because
Okay,
in
so
the
write
in
it
the
for
problem says that it's gonna be a greater and equal than a over b.
You guys are stuck with x and y. That's fine. Go for it.
This is reminding me of something I saw in calculus. And
No, don't go there.
no,
Don't go there. It's not helping you.
I just want to remember what I thought then, so that I can be able to say like, oh, okay, that's not it. But I can't even remember what it was.
This is iterative, and I don't think you will find this in that too with the floor function. I don't think in calculus you're going to be you're likely to see it. Go ahead. You can erase
so-
some things.
Okay, let me erase the top. So this is from the original, from the derivation of that.
Yeah.
So I'm not changing anything here.
Mhm.
I'm assuming I'm getting y.
Yeah.
So why not just change it with a, I want to find the y plus 1.
So, okay. By computing y, what did you get?
By computing y, I'm getting the number of casual runners that I will get,
You would capture.
that I will capture.
In how many rounds? In P rounds or
No,
one round?
just in whatever, if I'm giving n, A and B, I can tell you what's the maximum number of people I can capture, which is this y value.
Okay.
And I'm trying to find out what is the y plus 1. If I want to find out when y plus 1 happens, can I find out that n? I want to be able to find that n number.
Mhm.
So instead of doing y, I do y plus 1, and then I solve for n.
Hmm.
Same stuff goes here. So n, b minus a.
But now your n changed.
My n is now means something different.
Okay.
We can call it n prime. So I'm gonna multiply both sides by a, so I get ay
Okay.
plus a, and I'm solving for n prime, so n prime less than or equal to ay plus a over b minus a.
Yeah.
So n prime is just the ceiling of this.
Yeah.
And that's the new number of series.
That's when
So
this
new
number
value
happens.
of the number of serious runners when things will change.
Yeah, when things will change.
Okay. That's clear.
Fair enough.
Yeah. And that way now it's just calculating in constant time, so
But why didn't it change until then? Because this was still, this wasn't bigger than y plus 1, that's what you're saying.
yeah,
So that's why I was asking earlier, is it always going up by 1?
I think so. Because it's the floor.
Yeah, that part I don't know. I'd have to think about it more. It probably is, it does make sense that it only goes up by one. But if it's only going up by one, we can write another formula for that as well. Because it's just gonna go up by one, and so where is that next threshold?
That's what I got, right? I assume it's going up by one. And
Or you can reapply the same one you're saying. Oh, because it's independent of n. I see.
Mhm. Yeah.
What happened to it?
Well, n was there. And this is just n prime. I'm assuming just finding the next n when this changes. If I know y.
So you do have the code written up and it worked?
Mhm.
Okay. All right, for those of you who weren't completely up on the discussion, feel free to ask questions and I'll try and answer. Or else you can just let it go and we move forward.
How did you figure out to use n times b minus a?
That came from this calculation here.
Yeah.
So, he said n divided by n plus y, that's your
Which is
x
the-
divided by x plus y, right? Is bigger than a over b.
Okay.
That's what we were told. So why not, he's saying why not just use all of n, right? To be the number of the series runners.
Mhm.
Then when you do all the algebra here, take this over there, and subtract, move them forward, move them around, blah, blah, blah. What you'll get is n times b minus a divided by a is bigger than or equal to y. All right? Then, so that gives you that y is equal to the floor of n times b minus a divided by a. Okay, that's the
Oh, okay.
That's
So,
the number of
casual runners.
casual runners we can change in any given iteration, right?
Mhm.
Alright.
Now, the question he's asking is, when will that ever change? When will that become 1 plus 1? When will you now be able to convert one extra person in each round? In order to figure that out, you just, instead of y, you plug in y plus 1, and this time you take that same y that you computed from there, plug it in here, and you will get the n prime, which tells you at what value of n this will change. And then from this n again you go back to y, and then I think you can just keep
Yeah.
flipping between n and
Mhm.
y and,
That's what I
and
did.
essentially solve the problem.
Yeah.
All right, maybe we'll try and write this up a little more cleanly, and you guys can tell me whether it's making sense or not. Okay, how are we doing on time?
It's 4:27.
Okay, let me talk about some problem. Let's talk about the geometry. At best, we'll be able to understand the problem.
Can I see a picture of the last problem?
Of course.
Mhm.
It's all recorded anyways, and there's also
Yeah.
live streaming, so feel free to go and look at this.
Is there a solution as well that I can look at and analyze, or no?
I can send my solution on Discord.
Okay.
Yeah.
All right,
How long did that take to solve? Like, for you?
I did not get this during the contest.
Oh, okay.
I got this after.
Wait, what level was this? What level was that?
I don't know.
That was, sorry?
Like, what level was that?
Level?
Yeah, like,
I don't think it's.
oh, it wasn't part of the thing.
It's not part of the competition.
Oh, well, it wasn't part of the competition. Okay.
Are you done taking
Yeah.
pictures of this?
But I also feel like I may not be understanding the question and I might be on a completely different like path. And I want to see this at home.
Fair enough. Okay, time to read this new problem. Geometry for you.
Oh, any questions?
Okay, everyone finished reading the problem? You want to summarize for us?
So you're given some set of points, and for each point, there's a corresponding line segment.
Yeah.
The points are above the x-axis. The line segments are on the x-axis,
Yeah.
and you want to draw line segments from points to their corresponding line segments, such that they don't intersect, and such that the sum of the lengths of all the segments drawn is minimal.
It's minimum.
And if there's no way to do it, then a negative one.
Okay, great.
What are the line segments in that?
So,
On the x-axis.
so let's go through this. Okay, so let me summarize one more time, and hopefully with some pictures so that it starts to make sense. You're given n pairs, n points and n segments, and the segments are all sitting on the x-axis, okay? And they're all disjoint from each other, meaning they don't touch each other, they don't intersect each other, right? And then you're also told that all the points that they're paired with are above the x-axis. Fine. And what you want as output, as he said, is to join the points with their corresponding segments in such a way that the total length you use is minimized. Okay? So let me show you with a picture here. There are some constraints. We can talk about this in a short bit. Right. Perhaps it's just best that I draw it here. So here's the x-axis, my wonderful x-axis, and then you're given a bunch of line segments on this x-axis. So let's make that a different color, make that fatter maybe. So here's one segment, here's another segment, here's another segment, and so on. Clear? So these are line segments on the x-axis. You're also given a set of points that are, the set of points are above the x-axis. So maybe the first one is here, the second one is there, third one is there, fourth one is there, and the fifth one is there. All right, so let me number them. So let's say I call this 1, 2, 3, 4, and 5. And let's call this as 1, 2, 3, 4, and 5. This is what's given to you. Okay? Your job is to connect the point with its paired line segment in such a way that when you draw those connections, they don't intersect each other, and it's as short as possible. With me so far? Geometry, all this is clear.
And when I say connect, it doesn't just mean at the ends, at any point?
No, it can be anywhere in the middle as well.
Okay.
So you just need it's just make a line from the.
You could
line
just
segment.
go with the line and that would be fine.
Does the line have-
So for instance, over here, let's see if we can even do this. Can we even do this here? Now, I could connect one with somewhere here, doesn't matter, right? I could connect 2 with somewhere here, doesn't matter. Now 3 is kind of stuck in the shadow and I can't connect it to the line segment 3. Maybe if this segment for 3 were farther, then I could perhaps connect it there. Okay? Obviously it's not going to work out in this case. So in order to make it work out, I would have to modify the problem. I would have
So it
modify
has to
the-
be a straight line, or not straight, but like no.
It can't bend and do funny things.
And
Straight
then
lines.
You have to
Everything is.
move the 3 accordingly.
Sorry?
You have to move the 3 to make it so that it.
You're told which one is 1 and which one is 2, so they're all clearly labeled. 1 has to be paired with the segment 1, 2 has to be paired with segment 2, and so on and so forth. This is what's given to you. And I wrote down here that the line segments are nicely sorted because they're disjoint. I can sort them. I can label them 1, 2, 3, 4, 5, right? And the points that are sitting above the x-axis, they can be anywhere they like as long as they're above the x-axis. And that's where the problem is. If they're sitting nicely on top of each line, well, I could just connect them. Boom, boom, boom. Nothing would ever intersect. But because they are strewn all over the place, I can't quite do this. And even if I can do this, I have to make this as short. I have to make it as short as possible. I have to get the minimum possible length. All right. So this is the problem that is given to you.
And each point is gonna connect it to one segment only?
Yes. Yeah, it's cleanly labeled. 1 and 1, 2 and 2, 3 and 3. No.
It's gonna be like this 1, 2, 1, 2, 2, 2, or no? Doesn't matter the
No,
order.
you can't mix them up. No mix and match.
So what do we have
Oh.
to do to like what's the end goal? Like do you have to create the least amount of.
You have to connect them, and you have to connect them with the least amount of. So think of this connection as a wire.
Mhm.
Okay, here's another connection that's a wire, and I know I'm drawing it a little curvy, but imagine that it's straight, and 4 goes here, and 5 goes here. The total length of these 5 wires should be as small as possible.
I see. So it can be curved. Like,
No, it cannot be curved. I'm just drawing it. So I'm gonna move that, because otherwise you guys will ask me these questions and I won't be able to answer them.
Okay.
All right, there's my point, number 3. Three moved. Yeah. Okay. Now this may not be the smallest possible. It's possible. You have to make it as small as possible.
can't you just use like some sort of displacement formula to find out, like what, how high and how far apart it is, and then find out like the differences between each points and use that to find,
But that won't help you. It all depends on where these line segments are. So you have to take all that into account together. It's unclear how you really do that. So let's start with some simple cases and then see if we can start to build some intuition. Is everyone clear about the problem? And there are a couple of constraints here that's useful to know. Just keep that in mind. The number of points can be as big as 10 to the 5, which is 100,000. And the coordinates can be as big as 1,000,000. That's typically not of major concern. The one that's of concern is this n. This says the number of point segment pairs can be as big as 100,000. The take home from there, if you're paying attention to all of this, is that you shouldn't be coming up with an n squared algorithm because n squared will kill you. Okay? You're fine with an n or n log n. Anything more than that, yeah, you're probably not going to get it to work. Is that clear? Okay. So here's a simple case. Let's call this the triangle case. Let's assume that that there's only one pair, one point and one line segment. Now I'm calling it a triangle because it sort of looks like a triangle here. Remember, each point can have, let's see, make this yellow. Each point has a triangle associated with it that says somewhere in that, within that triangle, my line segment has to sit. The same thing with this here, and same thing with this here, and same thing with that there, and so on and so forth. Is that clear?
Mm-hmm.
Now, if you have only one triangle, which means you have only one point and one line segment, this ought to be easy. So let's see if we can figure this out. So here, what's the problem? Our problem is to connect that point with that line segment, but making sure what? It's as small as possible. And how do you do that? Well, again, there are actually two cases. One is that the point is directly above the line segment, and the other is if it's not.
It can touch anywhere, you can make the line anywhere along the line segment, so if you.
That's right. So this is my point, and I can connect it anywhere I like. And if I can connect it anywhere I like, where would I get it to be the shortest? If it's a perpendicular draw, right? So that's clear to you. And so we've got an answer for at least this case, when the point is directly above the line segment, so you just perpendicularly drop it. And the nice thing is that, remember, your input is going to tell you the coordinate of this point and the coordinates of this line segment. And so therefore, figuring this out is actually quite easy, because this is the x-axis. This here, the length of this red segment is simply the y-coordinate of that point, right? So far, at least one easy case we know how to solve. Now, what if it's not directly above? What's the picture going to look like? So if the point is not directly above the line, then what do I do?
Well, you're gonna have to find the furthest point from the bottom segment.
So all of these are examples of it, right? So here, this guy is not directly above it, and so what do I do?
So the furthest point on that 5, since it's not directly above it, but it's on this side, that furthest point from the
This
beginning
one here?
line, connecting it straight to that, because that
Right.
would be the shortest.
So there are only two possibilities, either the left end or the right end, and one of them has got to be shorter than the other. And whichever is closer is going to be the right one, just as she pointed out. So this also is easy. That's a picture that tells you the top of that triangle is your point, and the green line is the line segment. And so clearly the one that's closer, and it's easy to figure out because you can look at the x coordinate and figure out which one is closer, and you'll be done, right? So far so good. So one triangle case is easy. At least we know how to deal with this if we don't have any other confusing cases to deal with. This is useful for us to understand, right? And also over here, the length of this line segment, how do I compute the length of this line segment?
Oh, that's the
Cartesian
distance for.
It's just the Euclidean formula, because you have the coordinates of this guy, you have the coordinates of this guy, just plug it into the Euclidean formula. Done. Great. So we know at least we're in charge here. Now let's talk about what happens when things are not as simple as the ones I just showed you. So if you have only one point and one segment, the pairing is easy. That's n equals 1, and that's what we just said. N greater than 1 is what we want to deal with. Now, here again, there's an easy case. The easy case is when none of these triangles intersect. Well, actually, there's even an easier case. If every pairing allows for a vertical line segment, remember, two vertical line segments can never intersect. Why?
Because it's parallel.
Because they're parallel, exactly. So therefore, if you can draw vertical line segments for every pair, just do it. That's going to be your best answer. All right, done. So here's another case that also is easy. Even though they may not be exactly vertical, it's possible that if none of the triangles intersect, I'm drawing these triangles as regions where that line segment is going to be. If they don't intersect, well, I'll just solve it the way I did it for n equals 1. All I have to do is to pick the shortest one in each one. Yeah.
For if all of the shortest lengths are vertical, can you just have 2 points stacked on each other and then two segments?
I think you're not allowed that. You're told, if I'm not mistaken, they said that that's never going to happen because the line segments never intersect. They're all disjoint.
Yeah, but 2 disjoint line segments and then 2 points on. Oh, actually,
They can't
no.
be vertical.
Yeah.
Right?
Yeah, never.
So
mind.
that'll never happen. In this case, it could, but here I'm assuming that the triangles
I
don't
see,
intersect. Again, it's an easy case. I'll just find the shortest one for each triangle independently and arbitrarily. Good? So these are all easy cases. We're getting rid of them so that they don't clutter our thinking as we move forward. Now, if all the, so this is the last case, that if they're all non-intersecting, if the triangles don't intersect, it's easy, okay? Now, so let's move on. Let's deal with the next harder case. We have n is bigger than 1, but if the shortest line segment you do for each of the triangles, if those turn out to be non-intersecting, again we're in good shape because we'll just take the shortest. What if some annoying pair of these shortest line segments ends up intersecting? That's the case that we have to worry about. Now, I'm not saying this is we're going to design our algorithm this way, but this is just so that we build some intuition for this. So the question is, what is this going to look like? Life does get more interesting now. The question is, what does this look like? Can we draw a picture of something where this happens? Well, we did draw one picture by accident earlier. If this 3 is a little further away, it's not going to work out for us, right? That's when the shortest line segment ends up intersecting each other. Are you clear about this? Okay. So I think I have another picture here to help you. This is the easy case, but then if I have a second point that sits right there, and if its corresponding line segment is right here, then you're going to have trouble.
So what you want to do is that point, since you can't intersect, you want to find the point that's where that is
Correct.
where it lands, and then find one.
So you're going to have to take the instead of taking the vertical one, which is the shortest, you're going to have to take one that
Is
goes
one, yeah.
past this. You okay with that? So so these are ideas that we have to develop in order to solve the bigger problem. Okay. So if you have only 2 triangles like this, and if the 2 shortest line segments intersect, then yeah, we have to move something, but we don't know how. So the question is, what exactly is the approach, and how do we take care of this? In order to help that, we also need to understand when is this solution never going to be possible. what are impossible situations? Or is that something that we can characterize? And if we do that, then we have some hope of solving the problem. Is that clear? Okay. So you want to help me with this? What's a situation where it's completely impossible? Yeah.
It's if the points, let's say they're on the same line,
Mhm.
and this one belongs to this one right here, and this one belongs to this one that's right across here, and then so for example, this point and this point are on the same line. This one, this is 4 and this is 3, right? But then you have 3 line here and then the 4 line here,
Uh-huh.
and let's say you have something that's like right here. So no matter what, it's going to intersect, so you can't really control it.
That's good, but we need to make that more compact. We need to come up with a clearer example where this can be characterized, because then we can look for it. And then have the algorithm tell us that because of this reason, we're never going to find an answer.
All the points are like stacked on top of each other?
Stacked on top of each other is good, but that's a very special case. What if they're not just exactly stacked on top? What if they're a little off along the vertical?
Okay, so like they can touch, right, but not intersect, right?
The
Like,
lines,
the line segments.
the line segments, the link segments can touch, but
Yeah.
not.
I'm gonna suggest that, like, anytime there's a point and its line segment in between a point and its other line segment, it's always going to be impossible, right?
Say it one more time.
Like, if there's a point and its line segment in between any other points and its other line segments.
No, but then we saw in that other example that we could move this line so that it shifts and it works out, right? I mean, you remember the previous
No,
example?
I mean, like, it's completely in between.
Uh-huh. What does that mean? What is
Yes.
completely in between? I don't quite follow.
Sorry, I have to.
That way. I see. Yeah. Sure. If all the line segments from there will end up, is that the only case where it's not possible? That's my question. Yeah.
I was going to say, although I'm not sure if based on what I just heard, it's already been said. But if you have some pair of points and segments where any line segment drawn from one point intersects both edges of the other's triangle, then it's impossible.
You're saying even if there's one line that touches both of them?
No, all lines.
All
If all
lines.
lines
Yeah,
intersect.
that's her case. But my question is that the only case where it's not possible?
Well, to find all cases where it's impossible, one thing I noticed is that this is sequential, right? The bottom
Yes.
line.
Bottom is.
So we wanna find this, like the order of this,
Mhm.
and we wanna find the heights. If this is something that's like, let's say, right, this is shorter, this number
Yes.
2 is shorter than the number 3, that
Yes.
causes an issue because number 2 is sooner. So no matter where you hit number 2, you're going to
Yeah.
get that thing. But with number 3, because this is shorter, like, no matter what, it's,
No, you're definitely getting the intuition, but how do I write it compactly so that I can turn it into an algorithm?
oh, you get the
Remember, it's
height.
got to be coded in the end.
You get the height, you find this, where they're all.
That's not precise enough. Heights are, even if it's off by 0.01, is that going to be too much, too little? I don't know, right? Because even if the heights are off, much depends on how much off. And then the angles need to be right. How do I characterize this in a way that this is made precise? That's the hard part here. So should we keep the suspense until next time? 4:50.
Yeah.
Let's stop here. Okay, come back and you'll hear the rest of the